This is 3.2, part 2, solving polynomial equations algebraically. Here's what we want to do. Basically, we know how to solve quadratics when it's ax squared plus bx plus c. Right? We can set them equal to 0. We can solve them. We can factor it. We can use quadratic formula. Right? So what happens when we have problems that kind of look like the quadratic? We have three terms like this. So 1, 2, 3, except for normally the middle term's an x squared, and the first term's an x squared, and the second term, the middle term, is just an x, right? But here, this is an x to the fourth, and this is an x squared. Well, it kind of looks like a quadratic. So what you can do to test to see if you can use quadratic form in order to do it is take that second smallest exponent, and if you can times that by 2 to get the bigger exponent, that means it's basically a quadratic. So then if it's in quadratic form, you can take this as your a, this is your b, this is your c, and you can do quadratic formula, or you can do cab, right, to factor it. Okay, the way that the book kind of shows you is how to rewrite it. So basically, instead of just saying, oh, since I can times this by 2 and get 20, and I have three terms, that means it's quadratic form, then I can just say this is my a, this is my b, and this is my c, and I can go ahead and cab it, or quadratic formula. What the book wants to do is you use a substitution. So go ahead and let x to the 10th equal u, or any letter that you want to. The book will use u. Okay, so then I could rewrite this as 6u plus 15, and then that means that for x to the 20, the x to the 20 would be u squared, because if I times that 2 by 10, u squared would be x to the 20th, right? Because 2 times 10 is 20. And then you could do quadratic formula this way. This is your a, this is your b, this is your c, and you can go about that, right? So that's the way the book wants you to do it. It wants you to substitute like this: 4x to the 10th squared plus 6x to the 10th, and then plus 15, and then it wants you to write it like this. Okay, so that's for your check that you're going to have to do here. So I can just say, basically, if I can times this by 2 to make this one, oh, it doesn't. That's 16, right? Well, what about the other way? What if I times this by 2? Do I get 8? Yes, I do. So I just need to rework it. So 180x to the 8th plus 18x to the 4th minus 28. I have three terms, and I can times this one by 2 to get to the larger one, so it's in quadratic form. So the book, again, this would just be your a, this would be your b, this would be your c. The book wants you to write it as 180 x to the 4th. That is squared, because that would make 8, right? And then plus 18 x to the 4th, and then minus 28, and then you can plug in your u. U would therefore equal x to the 4th. U is always going to equal that middle term, whatever that middle term is, right? That's what u is always going to equal. And then so I can say, substitute in u squared plus 18u minus 28, and then you could do quadratic formula or try to factor it. So you notice on this last one, when I take the smaller one and times it by 2, I only get 4, which is not 6. So that means that this is not, I can't do quadratic form on this, so this is prime. Okay, so then it's actually solve a problem instead of just reworking it. So I have 3, and I take the smaller exponent, times it by 2, that equals the bigger one, so it's quadratic form. So I can either substitute u in, let u equal x squared, or I can just say, oh, there's my a, there's my b, there's my c. And I could do cab, c times a is negative 12 times 8, which is negative 96, and my b is 10. So what times what is 96, but subtracts to 10? Do a little work. It is 16 minus 6. So then remember, when we're solving, all we do is just take the opposite of these. So that'd be negative 16 and positive 6, and then we divide by our a, which is 8. So that means that one reduces to negative 2. This one reduces to 3/4. And then normally it's x equals, right? Because normally our middle term is just x, but now our middle term is x squared. So these are not going to be equal to x, they're going to be equal to x squared. So then I need to simplify even more by square rooting to get rid of that squared. So then it's x equals square root negative 2. Take out that negative, put an I in front, and then it's plus or minus, right? Because every square root is plus or minus. And then this one, square root. When I square root a fraction, I can just square root the top, and then square root the bottom. And then again, it's square root, so it's plus or minus. So my other answer is plus or minus square root 3/2. Okay, so that's it. So you can go ahead and do your check.